Till now, we talk about symbolic reasoning, quantum neural networks. Is it possible to have one system for all of them? Okay, simply we have one mind. And it's possible. And what we need to do is suppose currently we are playing with neural network, we have a bunch of vectors. And what we need to do is to blow these vectors into a sphere. And we have a sphere configuration. Now, if we take these centers, this will be the neural network talk about. And these boundaries, we let them precisely encode symbolic structure. Okay. Then the sphere configuration have both neural and symbolic AI. That's the idea. And as an introduction talk, I will first motivate why sphere and what is neurosymbolic AI. Here we should read it very fast. It's not a bag of two different things, rather one thing, okay? And then I will talk about this, how powerful is this sphere neural network in reasoning and in classification. It's stronger than either, or both, let's say. So why sphere? Let's do a thought experiment. Suppose you are invited to go through the maze. And you are reluctant to do it. And I give you, don't worry, there is a router instruction, and it will guide you, go through the maze, and then it stops in the middle. And what would you do? Train a neural network. We have data. So we cover something and use the content to predict the covered router instruction. That's what the current system do, okay? And then we have a neural network. For the unknown router instruction, we just take the most recent content and let it predict the current, the next route, okay? Since 2019, I tried to sell this neural network, neural navigator. No one buys this. Why? Let's think about it's not a maze, not 4 direction, rather 12 direction. And it's music sheet. Okay, then the task is turned out to be a composer is writing a music sheet and it's not finished. And we will using a neural network to finish this music sheet. All right. This is actually the Beethoven 10th project. The Beethoven's 10th symphony is unfinished, and there's a deep learning system to finish. Let's see, there's a voice. People pay for CD, but do not pay for my neural navigator. What's the reason? Same mechanism behind. Because I showed you this structure at the beginning, and you believe next route is determined by the structure, not by the past route or by the route of other mazes. Okay, we're finding the function of system 2 of our mind is by follow rules. Enjoying music, system 1 is about harmony. Okay, that's 2 different things. So the question is how. So just the harmony structure should be represented different way. It is not a way of consistency, and not a way of harmony. The question is how the spatial structure is represented in our mind. And there are sufficient psychological experiments on this topic. For example, people are asked what is the relation between San Diego and Reno decades ago, 1970s. Most people make mistake. They say San Diego is located further west, but it's wrong. What's the reason? When most people make mistakes, and for psychologists, they try to find the mechanism behind. So error for them is a window to explore how mind works. Okay, they do not say, and people try to collect more data. Their answer is our mental representation of spatial knowledge. The basic component is regions. What we have in our mind is just three relations. San Diego is in California, they know for sure. They know Reno is in Nevada for sure. And they know San Diego, they know California is west of Nevada. That's all, three pieces of knowledge. They do not know the relation between San Diego and Reno. So they construct a model, okay, and then inherit the relation between San Diego and Reno from their parent node. So what is neurosymbolic AI? It's about, let's say, reasoning is a process. Here is the reasoning is a process of construction inspection. So let's say the first is San Diego in California. The second is Reno in Nevada. The second is the relation between California and Nevada. From this, our mind construct a model. Okay. If we look carefully, here is a syllogistic relation. San Diego's inside is part of California. California disconnect from Nevada. The west is kind of disconnect. So no California is Nevada. From that, we conclude, we draw, we construct Euler diagram and say San Diego is west to Nevada. And then continues, Reno is in Nevada. Do it again. We do a construct model for syllogistic reasoning. And then for that, we inspect the relation between San Diego and Reno. All right. So what we have is syllogistic reasoning, the microsome of rational reasoning. How is our mind reason with syllogistic reasoning? If we look at this relation between segment A and segment B, it's obvious for us that segment B is longer than segment A. But we look at the same. Why? From this background, our mind constructs a 3D model and inspects the 3D model. And then say segment B is clearly longer than segment A. So it's evidence for model construction and inspection. All right, that's a Miller-Ley illusion. So what is neurosymbolic AI? Its representation is simply sphere configuration, and reasoning is a method of model construction and inspection. Okay, just two things. And then what I'll convince you is that this sphere neural network reach symbolic level syllogistic reasoning. And what I will spend time is to show supervised deep learning cannot reach the rigor of symbolic level syllogistic reasoning, no matter how much data you have and how rich you are. I mean, how much GPU you can buy. Okay, and most of the people assume it's a simple task, maybe already solved, but we never will. So what is syllogistic reasoning? Are we familiar with the reasonings that all Greeks are human and all humans are mortal, therefore all Greeks are mortal? So syllogistic reasoning quite simple, only two premises with one conclusion, and the reason about three concepts and limited for relations. So we can have, let me see, another syllogistic reasoning says no Greeks are philosophers. Also, some Greeks are philosophers and no philosophers are rich. Therefore, some Greeks are not rich. All right. So think about what is the rigour of reasoning. Means we need to distinguish four values of this syllogistic reasoning. For that, they can be valid. Means if premises are true, then the conclusion must be true. So if all x are y, all y are z, then it must true all x are z. So some x are y, no y are z, then we conclude some x must not be z. Unsatisfiable means as long as the premise is true, the conclusion is false. Okay, cannot be true. So if all x are y, all y are z, say some x are not z, if we move out of, it will violate the relation that all x are y, such like that. And this means unsatisfiable. And there are similar cases that some x are y, no y are z. If we say all x are z, then it must be violate other premise that some x are y. Invalid means, given the premise, there is a counter example of the conclusion. So if some x are y, no y are z, some x are z, we can move out of it. Okay, have a counter example. Satisfiable means, given the premise and conclusion, there is a configuration satisfies three statements. Okay, so here, if it's here, then it satisfies three statements. Rigour of syllogism means, given three statements, okay, two premise, one conclusion, it should decide it's valid or invalid or satisfiable or unsatisfiable. Okay. And what I will convince you is that there's no neural network can do that. Okay. Who believe they can? You can. Okay. Now wait. Human can, right? Not all, but logicians can. But there should be a neural network that can do that, right? Some human can do that. Let's assume yes. Yeah. Let's suppose for any x, y, z, a neural network can determine for sure that for sure means hand accuracy, the all x are there. Yeah. Because it's for all elements, so we can say all Greeks are human, all Italian are human, all Indonesian are human, and then there must be some out of distribution. Say all Chinese are humans, and seldom disappear, seldom exist in the corpus, and then the network have some problem. So to simplify the task, we just restrict. We set input are Euler diagram, circles. Okay, then we only all x are z, it means the red circle is inside green circle. All y are z, means there's a green circle inside a blue circle. Then we need to define or design a network, and the output is a red circle inside a blue circle. Okay. Actually, the Euler net is designed in this way by our colleagues 2018 and 2020. They use CMA network to encode the input image, and then using reasoning network to give output. To simplify the task, the output is a flag to denote the relation between red and blue. And then they connect, let me see. So the training data is collected by the combination between the input and the output. Okay, so giving red is distinct from green and blue inside the green. So they assume the reading network will learn a latent representation of Euler diagram and then output the relation between blue and red. So then we have a combination table. Okay, and collect all these kind of input output. These are the combination table. They collect 80,000 training data and using 8,000 validation, 8,000 testing, and reach 99.8 accuracy. Does this network learn syllogistic reasoning? Only 0.2 point misgate gap. Unfortunately not, never. If we look at all the 24 type of valid syllogistic reasoning, the table only covers 8 of it. Many of 16 types are not clearly covered. The reason is that some WRU is corresponding to 3 columns, and some WR not U also 3 columns. So it's not one-to-one mapping. So we need to very carefully design the combination table and try to establish a one-to-one map. So there is a syllogistic statement and there's one column. Okay, then we can see how to improve the method, whether we can get the training data. This is possible. There's also 3 here. So for some X or Y, there are 3 situations. And we can create this one says some X or Y means it is not true. X disconnect from Y. And we set the background as gray and make the 2 circles disconnect. Okay, then we have one-to-one mapping. Some X are not Y, also corresponding to 3. We can say it is not true, X is part of Y. And we set a negation. And so green is inside the red. Then we can design a very careful combination table. Then the premise is corresponding just to 1 column or 1 row. But again, there is a Barbara and Barbary version. What's that? Barbara means all X are Z. Barbary means some X are Z. So we cannot distinguish this weaker version. Okay. So in that case, if we're using combination table, for this strong version and weaker version, they will share the 100 accurate confidence. So just 50%, just like tossing a coin. There's no rigor of reasoning. The same, no X are Z, means some X are not Z, the weaker version. So we cannot have training data for all 24 type of valid syllogistic reasoning. It's too coarse for this method. And if we say this query key value is also a combination table, this follows transformer cannot. And large language model, they develop building block is transformer, so they cannot either. Then we need to question, is it possible we just train one type? Okay, we say the weaker version is not so useful, or so is there a supervised deep learning that can reason for sure that all Greek are human, all human are mortal, then all Greek are mortal? Can we collect enough data and then say this neural network is reason for sure? Actually, using benchmark, yes. However, what we do is that this network reaches 100 accuracy. if there is a situation that we only feed 2 single green circle, the network also output blue contain red. What happened? Obviously, the CMA encoded the latent feature vector, and this latent feature vector is similar to the image in the training data that have red and green. Okay, then the output, yes. Input are image pixels. Yeah. Okay. So in that way, if we want to reach the rigour, we have to train network that when the network got single circle input, it classifies as unintended, that output 4 zeros. We can do that. Okay. We train the network that when single input, it outputs 0. And if it's normal, it reach 100 accuracy. Is this network reach the rigour of syllogistic reasoning? Again, no. We can feed half, 4 green with half red and half green, half blue. In that case, this half circle is undetermined. Sometimes it's saying it will complete it as a 4 circle. The situation they ignore it as a single case. So this is undetermined case. And to make this for sure, we need to collect data again to define this is unintended or it is valid, completed automatically. However, in either case, it will create something in the middle, become unintended. So this process will never end. There's always unintended. And intended data is automatically generated by the training data itself. Okay. So if you're using training data, you will have out of distribution data. If we say this partial is not good, single circle is partial intended, and partial intended input automatically generates new partial intended data. So we cannot exhaust unintended data. And this is actually not for reasoning, this is unintended. But for object recognition, is a good feature. We see part of it, and we know the whole. And this is for computer vision, it's the intended feature, and they're proud of it. The first feature is that 20%, 80% is covered. We only see 20 and the system can recover whole. And in the video case, if the first frame is recognized, the second only need 5%. The network can recover it. But the problem is that when reasoning, we establish end-to-end. Then we introduce contradictory features of object recognition that is desirable, that recognize whole from part. But for reasoning, this is forbidden. And then this is contradictory feature in one end-to-end mapping. So we can then solve the problem. So what we will do is that we just using create sphere. Then the problem is disappear. We don't need training data. Okay. So if we question, is this reasoning satisfiable? Some SRM, no TRM, and follows some SR, not T. Suppose this is current configuration. Then we need to construct a 3 sphere that satisfy the 3 statements. Some SRM means M is not disconnect from S. So we fix S, we move M to it, satisfied. Some S are not T, so S should not be part of T. So we move T a little bit away. And the last statement, no TRM, we need to update M and without breaking the already established relation with S. So it will rotate around S and then move away from T. As long as 3 states are satisfied, this is configuration, and the network will stop and say the reasoning is satisfied. Okay, no training data. And the question is, oh, is this reasoning valid? To show this valid means there's no counterexample. So we need to negate the conclusion. It says some S or T means all S are T. Then we repeat the whole process again. Okay, so if this is a starting configuration, some S are M. If we fix S, we move M towards S. All S are T already satisfied. We don't move T, and no T or M. If we fix T and move M, oh, it cannot satisfy 3 statement. And the question is, if we argue this network is reason for sure, and this will run into a never-end loop. The good thing is that we theoretically prove for any satisfiable statement, the sphere neural network can construct an Euler network without error in one epoch. So after one epoch, the system calculates the global loss is greater than 0, means not unsatisfiable. Then it stops, says the conclusion is unsatisfiable. So the original statement is valid. Okay, and this is the need a theoretical proof. Feature of the network is independent of data. How they do it that without using data, this network using a transition map. So to transform X disconnect from Y into the status of X inside Y, it will look at the map. The next neighborhood relation is partial overlap. So it using the transition function delta D to PO, it gradually transfer Y to, transfer Y to X. This means shorten the distance between the central point or enlarge the radius till they connect. Then they look at the map again, PO to P. They take the delta function PO to P. This means you need to continue to enlarge radius and shorten the distance between central point till the P relation is held. Okay, then stop. So to compare with deep learning or ChatGPT, our network do not use training data, so there's no out of distribution problem. It covers all 24 types of syllogistic reasoning. Is explainable because it constructs Euler diagram, and it's a reason for sure because it clearly know when to stop. Okay. So next question is classification problem. It's also a very a common problem in AI. Classification problem is suppose we have a taxonomy and we need to classify things. The apple can be a fruit, can be a tree, can be a company, or can be your laptop. Okay, and giving a sentence, we need to identify this sentence in this context. It's which sense it is. Okay, it's a hard classification problem for symbolic AI. The reason is that if we using supervised deep learning, this taxonomy structure is never truly encoded in the embedding space. Okay, it's matched. Just people say it's like Texas cowboy. They shooting very good, but they shooting first and then they draw the target afterwards. to get a best fit. So our method is that we can make them create a nested sphere embedding to precisely encode this taxonomy. Okay, then the classification is the shooting task. So if we say he cashed a check at a bank, in this sentence, bank only have one sense. Okay, and we know immediately it is an institute. Okay. Oh, here so the map is not correct here. Apologize for that. So the idea is that we take the context vector and put it together, and then we just using a network to shoot into the target. And here the target is not correct. It's the Apple case, not the bank case. You need to change that. And then our experiments show that it's the current word sense deep learning accuracy is 80%, and the ceiling of deep learning is 90%, and this method can reach 95%. So it's above the theoretical ceiling. So then we need to say, how far can this method go? Okay, we cannot only solve syllogistic reasoning. Actually, we can solve a variety of logical reasoning. Let's say here is the disjunctive syllogistic reasoning. So if F follows G or H, and if F is true, then G is not true. This follows F must follow H. What we do is that we fix the universe as a circle. Then a sphere on a circle is an arc. And then the complement is also an arc. In that case, we can introduce a negation set, the negation. Okay. So we can represent this way. We construct a Euler diagram as circle by rotating arc. Okay, if it's satisfiable, it's satisfied. Okay, the conclusion is satisfied. So I think it's good. So summary of symbolic AI is that we propose sphere neural network. We introduce the radius as greater or equal to 0. And then the current network is a special case that all radius is set to 0. Okay. And then we introduce using the boundary to capture symbolic structure. And the center is to learn from data. Okay. And then we have both of it. And this is the first neural network that reached the rigor of symbolic syllogistic reasoning. So here's some advertisement. We organize a workshop at AAAI. We call it new meta AI. So challenges sitting there. I am there. The tool is not there. I think I can finish talk and take questions.
Thanks for the talk. Are there any questions?
Thank you for the talk. Very nice. I have a question is that I did not understand completely how is the architecture of the neural network. So can you explain a little bit better how do you, because you've talked about arcs, but then your architecture is only about circles and centers. So I don't understand how you can codify the arcs within the network.
Oh, back. Let me think. Yes. Where is the first?
Play on this Mac, please.
Okay,
Go
then
there.
click. Okay, then we do
Do
the
this.
animation.
Yeah.
Just let's finish. You mean how the arc case?
How do you represent an arc in this architecture?
Yes, if the universe is just a circle, and the sphere is just the century and the radius, all the points that less than a fixed distance is a sphere. So if the universe is an arc, then the sphere is just the universe is a circle, two-dimensional circle, and sphere just an arc. Okay, and we can define complement set is also an arc. Then it's closed. Yeah. Then the Euler diagram is we are rotating this arc. Okay.
Thank you for the talk, very nice. I'm wondering for the case of images, you mentioned pixels at some point. How do you go from the pixel representation to your arcs or your spheres?
We don't need. The input of sphere neural network is a sentence. O, X, R, Y. Then X is a circle, Y is a circle, is in the embedding space, there's essentially the radius. So we can compute their relations between them. In sphere neural network, input are symbolic, but they create its circle in embedding space. No pixels. Just three statements. OLANet is input is pixel. Okay. No train. If we train means we need to use in data, and if we using data, then there's out of distribution data. No data. We just construct. We're using gradual descent to have a configuration. Okay.
Any more questions?
Thank you for the talk. Can you speak more about how the circles are moved around once the embedding is created?
Yeah. Let's say if we distinguish a status O, X, R, Y, then circle X should inside circle Y. And this relation is translated into an algebraic formula. So the distance between central point plus the smaller circle should be less than or equal to the radius of the bigger circle. So it inspects to see whether this relation holds. Okay. Then if it's true, then OX is Y. So if currently they are partial overlapped and the target is one should be inside the other, the delta function is a function, it also an algebraic function. It will reduce the century and also reduce the radius. They just do this loop till the P function is held. Then it know currently X is inside Y. It's just a simple geometric observation. No training it. So. In our experiment, no, if you separate too far away, it's slow. You just do where your descent is very slow. Okay. Otherwise, you can introduce in geometrical operation, just move it very fast. Otherwise, it's fine for syllogism.
Any more questions or comments?
Sorry, I didn't really understand how the embedding works from images or text to circle. How do you enforce the latent representation to be
First is
circle?
all four kinds of syllogistic statement is translate into spatial relation between circles. All x are y is circle x is part of circle y. No x are y, circle x disconnect from circle y. Some x are y means it is not true, x disconnect from y. Some x are not y, mean it is not true, x is part of y. So we're using part of as basic to define relation between circles.
So you're using mathematical relation
Yes,
as a
using
system.
geometrical
Okay,
relation.
okay, got it. Thanks.
Yeah.